Yep, so today I'll be presenting a science exploration architecture that we've developed for Phobos and Deimos. And specifically, we're interested in asking the question, is human exploration of Phobos and Deimos in the critical pathway of human exploration of Mars? And as you can see, this is a major collaboration with other Brown graduate students, as well as with our mentors, Ken Ramsley, Jim Head, and Carly Peters. So this project stems from the Survey-sponsored seminar, which was on Phobos and Deimos, and I know many of you are familiar with it because you lectured during it or tuned in on Adobe Connect on Monday afternoons. But for those of you who are not familiar with it, it was a graduate level seminar where we had different lecturers come in each week and present on different aspects of Phobos and Deimos science, much like we're doing this week. And following these lectures each week, our class met to develop a science exploration architecture that could help address some of these strategic knowledge gaps that were being asked in these weekly lectures. And specifically, we are interested in looking at the viability of using human exploration as a means of addressing some of these knowledge gaps. So when creating this architecture, we were firstly interested in addressing these strategic knowledge gaps and looking at the fundamental scientific questions that still remain in Phobos and Deimos science. And secondly, we're looking and assessing to what extent can Phobos and Deimos be used to facilitate the later exploration of Mars, like Mike was just bringing up at the end of his talk. And as he suggested, there are many ways that this can be achieved, whether it be through the exploitation of in situ resources, through the incremental development of technologies in the Martian system, or perhaps by providing radiation protection. So we had two primary questions that helped define our mission architecture. First, it was scientifically driven. We were interested in determining what is the origin of these moons. This is a main question that still drives a lot of the science in this field. And then, secondly, our class agreed that, of course, sending humans to the moons of Mars would be able to accomplish incredible science. But we also recognize that sending humans to the moons of Mars doesn't necessarily align with necessarily the broader vision of NASA or perhaps what Congress would want. During our course, we had the opportunity to sit down with John Grunsfeld, the Associate Administrator to SMD, and he challenged us to ask the question, do Phobos and Deimos lie in the critical pathway to Mars? So therefore, the second question that helped organize this architecture was determining whether to have a successful human program on Mars, we need to stop at the moons. So in true NASA fashion, we developed a really simple flowchart. It might look overwhelming on this screen, but I wanted to provide a broad context so you can get an idea of the flow that I'm going to take in this talk. Our architecture consists of 4 stages. The first stage consists of an orbiter mission where we're interested in helping define what is the origin of Phobos and Deimos. We continue on with lander missions that, again, want to address this question and also look at how these moons can be utilized to help with Martian operations. Stage 3 is interested in defining if it's safe to send humans to the moons. And then finally, we outline a suite of objectives that the humans can accomplish once we reach the surface of Phobos and Deimos. So I'm going to walk through each of these stages in a little bit more detail. So returning to stage 1, this is the orbiter phase where we're interested in determining what is the origin of the moons. As we were discussing yesterday, there are different formation models that have been suggested for the moons, including co-accretion with Mars, ejecta from a giant impact with Mars, or perhaps capture of a foreign body, possibly sourced from the asteroid belt. And each of these formation models has different implications for how these bodies can be utilized for Martian operations. So with the orbiter mission, we want to accomplish global maps of geology and geophysics and geochemistry. Continuing on to stage 2, this is a lander component where we're again interested in determining what the formation of these moons is. So I'm going to start on the right-hand side of this chart where we're looking at using the lander to help characterize the near surface and regolith properties of the moons, and also to help characterize potential landing sites and high fidelity. So specifically, we're interested in looking at characterizing the internal structure, returning an increased size of sample collection, and also characterizing the electrical and mechanical properties of the regolith. If these questions can't be answered, we propose sending another lander to help determine the formation of these moons. And then finally, we go onto the left side of this chart where we're looking at how these moons can be utilized to help with Martian operations. So specifically, we look at whether Phobos or Deimos can provide any radiation protection, as Mike was just talking about, whether we can integrate a telecommunications presence, and finally, if there are any volatiles present on these bodies. If there are volatiles present, we need to look at whether they're useful as water or fuel or potentially any other resource, whether they're present in any sort of usable abundance, and then, of course, if it's economically feasible to utilize. So as you can see for each box, you can either select yes, and that continues down within the mission architecture, or you sort of end up in one of these stop signs. A stop sign doesn't necessarily mean that Phobos and Deimos do not lie in the critical path. Instead, a stop sign is representing that perhaps Phobos and Deimos fail to have this potential merit. So we don't suggest that if you land in a stop sign, you halt all surface operations for human exploration, but instead determining if Phobos and Deimos can be useful in the human exploration of Mars. It's more of a weighted algorithm of these stop signs. If we do determine that Phobos and Deimos can be utilized in Martian operations, we continue along the mission architecture and then have to assess whether it's safe to send humans to these bodies. So specifically, we have to characterize the debris environment. The dust situation that we've been discussing is something that needs to be addressed. We need to quantify the radiation effects. We also need to look at the biomedical gravity effects on humans, characterize the global and rotational states of the moons, and finally understand the gravitational field. If we don't understand all of these different questions, further missions are required to answer them. And if we do know the answers, we need to ask, is it safe to send humans to these bodies? And can humans operate in such strange gravity environments? And with 2 yeses to these questions, we suggest that it's appropriate to send humans to the surface of Phobos and Deimos. And finally, stage 4 outlines a suite of objectives that humans can accomplish once we get to Phobos and Deimos. Specifically, we can accomplish lots of science that we don't detail here, but we can also set up and operate an ISRU extraction base. We can practice operating in strange gravity environments. We can build a telecommunication base to increase our telecommunication presence with Mars. And then finally, construct and utilize potential radiation protection. So as we've been discussing, there are many questions that still remain regarding the nature and the origin of these moons, and future robotic missions are required to help answer these. But future robotic missions can also help us determine how these bodies can be useful when thinking about Martian science as well. And so what we've done with this flowchart is help to address some of these questions that we need to be able to answer before going to these bodies, and hopefully determine how we can utilize Phobos and Deimos before having a human exploration program settled on Mars. So while we think that will always be beneficial to send humans simply based on the science return, what we need to be able to do is address the other ways that Phobos and Deimos can utilize the human exploration program on Mars. And as we've outlined in the flowchart and Mike discussed just before this, this can be in a variety of ways, whether it be through ISRU, radiation protection, 'or transportation and operations infrastructure. So thank you for listening, and I'm happy to take any questions.
Hi, I just want to say thank you very much for this wonderful presentation and for all the work you students did. Thank you for bringing to everybody's attention the Phobos Deimos workshop seminar series that was led by Dan Britt's team and Carly Peters' team. That is available online. Everything's been archived. And so for those of you who may have missed it, please go to survey.nasa.gov and you can see all the videos as if you were there.
Hi.
Hello.
Great job.
Thank you.
Great to see. I don't know if you said it. If you did, I missed it. Just curious, do you have a preference for Phobos or Deimos?
Yeah, I sort of referred to them as a unit here, but we talked mostly about Phobos. Firstly, for the science, I don't know, bigger is better, but we thought there were more questions about Phobos perhaps, and also there are a lot of more engineering constraints, we think, with Deimos, just based on the even more microgravity environment. Mike had a slide about that as well. I think the only benefit that's brought up about Deimos sometimes going there is it's perhaps easier to get to, but Phobos.
Okay. Is there an explicit choice between them somewhere in the flowchart, or
No, we
curious?
no, we didn't specify that.
Okay. Thank you.
You're welcome.
Any other questions? All right, thank you, Ariel.
Thank you.